Welcome to the second video of disaccharides. So in the first video we talked about sucrose. So in the first video we talked about sucrose, right? So we discovered that sucrose is formed out of two monomer units of glucose and fructose. So these are joined by 1,2 glycosidic bonds. And we have to remember that these two sugars here, glucose at carbon 1, that's where you find the carbonyl group, the aldehyde group. So glucose has aldehyde group at carbon 1, and the fructose has ketone group at carbon 2. So make sure you understand this. This is a very important point to take note of. So you find that this glucose has aldehyde group at carbon number 1, and this fructose has a ketone group at carbon number 2. So remember when we looked at the structures of monosaccharides, the structures that are open chains, we discovered to say the ketone and the aldehyde groups, these are the groups that are functional groups, and these are the ones that give you properties for monosaccharides to be reducing sugars. So as you can see, this sucrose is formed by the linking of carbon 1 and carbon 2 of the glucose and fructose, and these are the carbons that contain the functional groups. So that's why this sugar, sucrose, is not a reducing sugar, because carbon 1 and carbon 2 of glucose and fructose respectively are linked to form 1,2 glycosidic bond. So this just means that these carbons, they can no longer, or the functional groups can no longer participate in further reactions. So that's why the sucrose is a non-reducing sugar. So let's go now to the topic of our interest, which is lactose. So let's look at lactose. So lactose is just milk sugar. Lactose is milk sugar. So this one composed of galactose and glucose. So when you join these reducing sugars, or the monomers, galactose and glucose, you're going to come up with what call lactose, which is a disaccharide. So these are actually linked by 1 to 4 glycosidic bond. Take note. So lactose, the monomers are linked by 1,4 glycosidic bond. Between which carbons? So between carbon 1 of beta galactose. Shall we take note of this? So carbon 1 of beta galactose. And what else? And carbon 4 of either alpha or beta glucose. Yeah, so make sure you know the point as well. So for the galactose, it is specific. You have to use carbon 1 of beta galactose. But for glucose, you can either use alpha or the beta glucose to form this bond, glycosidic bond of lactose. So the formula is C12, then H2, then oxygen 11. So this sugar is water soluble, meaning it can dissolve in water. So let's look at the formation of this disaccharide, the lactose. So formation of lactose let's look at it. So we have galactose. We said it has to be beta galactose. So let's draw the structure of galactose here. So we have H2OH, you have H here, you have OH, we have H, then here we have OH, here we have H, then here we have OH, here we have HI. So we said this is galactose, and we said for galactose it has to be a beta. So that means the hydroxyl group, we are going to put it here at the top. So this is beta galactose monomer. This is the monomer of beta galactose. Then other one we have plus that of glucose now. So the structure of glucose is like this, have oxygen here, yeah. So we said it's open here. See that you use alpha or beta glucose. So let's try to use the beta glucose as well. So we have OH here, then we have H here, we have CH2OH here, so we have H here, we have OH here, we have OH here, we have H here, we have another H here, then we have H here, we have an OH. So this is the structure of beta glucose. So we said the bond is formed by the carbon 1 of this one and carbon number 4 of this glucose. So we have carbon 1, carbon number 2, carbon number 3, carbon number 4. And here we have carbon, this is carbon 1, isn't it? So we have carbon 1. So this means that let's push it this way. So just like the way we did for sucrose, this one will be a reversible reaction. So it can go forward and backward. So for minus, we are going to say this is loss of water, then H2O plus. So this is addition of water. So this is condensation. So condensation results in the formation of a disaccharide, but adding water, this is hydrolysis. So this means that you form the monomers of the disaccharide. So let's draw now the structure of the disaccharide that is formed. So we have this, this, so we have another thing here. Let's draw another one. For H here, H here, you have CH2OH, you have H here, double T here, you have CH2OH, you have H here, OH here, we have H here, we have H here, we have another OH, then we have OH here, we have H. So this will be hydrogen, then here another hydrogen. So we have glycosidic bond here. So this is oxygen. So we have beta here. So meaning the OH was up here. So we lost the OH. We lost the H from this one. So this side, since there was OH down here, so meaning we lost the whole OH here. And the oxygen for the OH that was here is the one that remains to become the glycosidic bond. So this is the glycosidic bond here, 1 4. So we have carbon 1, carbon 2, carbon 3, carbon 4. And we have carbon 1 here, carbon 2, carbon 3, carbon 4, 5, 6, Yeah, so let's also include the number 5 and number 6 here. So as you can see, this is 1, this is beta, we have to include the beta. 1 4 glycosidic bond, beta 1 4 glycosidic bond for the formation of lactose. So let's also understand now if this lactose that is formed here, whether it's a reducing sugar or not. So as you can see, the carbon 1 here, carbon 1 was used in the formation of a glycosidic bond for this galactose here, but here let's go to the glucose here. So this is a beta glucose. So for the beta glucose, as you can see on carbon number 1, since galactose and glucose, these are aldehyde sugars. So on carbon 1, that's where you find the functional group that participates in the reactions. So for this one here, on carbon 1, you have the free hydroxyl group, which can participate in the other reaction. So that means that the functional group, the aldehyde group, is free here to participate in the other reactions. Hence, lactose qualifies to be reducing sugar. These are the things that come in the test, so make sure you understand this point here. So let's look at some other coming up properties for this. Yeah, so we've already discovered to say lactose is a reducing sugar. So because carbon 1 of glucose is free, and that means it can participate in other reactions. And this means that it can form an open chain to expose the aldehyde group, and it can form an open chain to expose aldehyde group, because what is important is the aldehyde group for the reactions, hence it has the reducing properties. So lactose can be broken down into galactose, to galactose and the glucose by addition of water, which is hydrolysis. So that's all for the lactose. So make sure you subscribe to the channel so that you'll be able to see some upcoming videos. So the next video that you're going to make is about maltose, which is one of the last disaccharides, one of the last examples of the disaccharides. Thank you for watching to the video. Tune up more to the upcoming videos. Thank you. This is Onzadan.